Okay, this is a Monday morning, and this is November 20th. This is your 9 for warm-up for the week. So these questions, the top 3 questions have to do with reach back, having to do with both the chapter on fraction operations and integer operations. And the next 6 questions are both grade 7 questions and some of the grade 8 questions from chapter 10.1. So the first question is an integer order of operations question. It says -8 take away the product of -2 and +4. The first thing I'm going to do is multiply -2 by +4, and I get -8. And everything else just comes down right below it. So the only thing I simplified here was that, and I got -8, and everything stayed where it was. I now have subtraction. The easiest way to do subtraction is to keep flip change. I could also think of it just for a second and just pause and think about it. -8 take away -8. If you have -8 and you take away -8, you'll have nothing. But if you keep flip change, you actually see that it creates a zero pair, and your answer for the first question is nothing. In the second question, we have another order of operations question, this time with mixed fractions. The easiest thing to do is when you have mixed fractions in any operations, is to simply convert them to improper. I'm going to multiply first, which means this is not going to be done until after. I'm going to get 9 over 4. I'm now adding two fractions that don't share a common denominator, but when adding and subtracting, I do need a common denominator, so I use 4. I get 6/4 plus 9/4. That is 15/4, which is 3 3/4. And in the third question, it has 3 3/4, which is coincidentally the answer to the last question, divided between 4 people. If you share it, remember, when you have mixed fractions, think of them as improper. And when you have whole numbers and you're dealing with operations, it's always, if you're going to use an algorithm, it's nice to use over 1 when you have whole numbers. So 15/4 divided by 4 over 1. When you divide fractions, you should always multiply by the reciprocal. It's an easier way to get the answer. Multiply your numerators, you get 15. Multiply your denominators, you get 16. So your answer is 15/16. Okay. Now again, some people still get confused about common denominators when multiplying. If you got a common denominator there, it still wouldn't have gave you the wrong answer. You just would have had to reduce it again. Our next 3 questions are modeling to solve. So the first one says, in order to model it, you have to read it as a quarter of x is 1. So if you read it as a quarter of x is 1, then drawing it's much easier. So we start with our scale. There's x, but I don't have all of it. I only have a quarter of it. And a quarter of it is equal to 1. So I don't want to know what a quarter of x is. I want to know what all of x is. So I'm going to quadruple this side. I'm going to use my infinite cloner here because it's easy. I think it'll let me do it. I'll ungroup. And then I'll just take this part here. And I'll group that part. And I'll infinite clone it. So I'm going to quadruple this side. So double it, triple it, quadruple it. Oh, quadruple it. Maybe. No, quadruple, there we go. So I quadrupled, well, actually it looks awful now, but let's just take this and put little lines in there. There we go, it's a little bit better. So I quadrupled that side, and when I did that, I'm going to have all of x. But since I quadrupled that side, I have to also quadruple this side. And when I do that, I end up with x is equal to 4. X is equal to 4. In the next ones, it says solve with opposite operation. So it says x divided by -4, or a negative quarter of x. Another way to interpret this, here's 3 ways to think of it. You could think of it as a negative quarter of x. You could think of it as a negative quarter of x. You could also think of it as negative 0.25x. All 3 of those interpretations are the same value as the expression of x divided by -4. But since we're using opposite operation, since I'm divided, this is really x divided by -4. The opposite of that is to multiply by -4. So I'm going to show bracket -4, and that means multiply by -4, and I'm going to do it to both sides. Those are opposite operations. I'm left with x, and over here I have the product of -2 and -4, which is a +8. Not -8, but +8. And if I went back into the question and substituted 8 for x, if I erase this x and I put the number 8 and check 8 divided by -4 is -2, so the value of x is, I think I can do that. No, I can't. Oh, for heaven's sake. Oh, whatever, right there. X equals 8. And with the next one, it says model and use opposite operations. So the first thing I'm going to do is model it. So it says x minus 3, which we're going to use -3, equals -5. Now I'm going to apply 0 pairs here. So I'm going to actually add 3 positives to this side. I'm going to add 3 positives to this side, because whenever I do to one side of an equation, I have to do the exact same thing. That creates a 0 pair. So in my next picture, I have isolated the variable by having x by itself. And these 3 negatives here and these 3 positives here make a 0 pair. I'm left with -2. So x equals -2. If I use opposite operation, it says x take away a +3. So I'm going to add a +3, which is the opposite. And I'm going to do it to both sides, creating a 0 pair. X equals the sum of -5 and +3 is -2. In your next 3 questions, it says model to solve. So we have just a coefficient. So we have 4x's equals 12. And I'm lazy, so I'm just going to do a positive integer chip times 12. I'm not going to draw it 12 times. Now, if 4x's have the value of 12, then I'm going to make 4 little scales and say that if that's true, then each of these x's would have a weight of 3, or x has a weight of 3. If 4x's equal 12, then each of those x's must be 3. In the next one, it says solve using opposite operation. This says x multiplied by -5. So the opposite by multiplying by -5 is to divide both sides by -5. And we're not going to use a division symbol. We're going to use it like this because it looks nicer. You can use divided by 5 if you wanted to, or by -5. But I'm going to put a line through there to show that it creates their opposite operations. I have x equals negative divided by negative is a positive. A 10 divided by 5 is a 2. So x equals +2. And in the last question, it says solve with modeling and opposite operation. I'm going to do modeling first. So -2 plus 2x looks like that. Now your constant usually doesn't go in front of it's not usually the first part of your expression, but this time it is. It doesn't change the value, it just puts the order differently. Equals -10. I'm going to get rid of my constant first by adding 2 to both sides. That creates a 0 pair. And I have 2x's equal. Over here, there's only 2 of those 0 pairs. -8. And if 2 x's have a value of 8, then each x must have a value of 4. -4. Thank you. So x equals -4. If I use opposite operation, which it asks you to do as well. Oops, where did it go? What happened there? Okay. So I'm going to add 2 to both sides. It gives me 2x equals -8. Divide both sides by 2. X equals -4. Okay.